Top to the morning to you. All right, good morning, guys. It's Monday morning. Hope you're doing good. All right, so today we're going to do bonding. You need your iPads for today. Remember, I told y'all Friday you need your iPads. There is styluses at the front of the class. Hopefully, you grabbed them. I put them on charge this morning. Got here early today before I had to leave. They're all charged, so please grab one. If you don't have one of your own, please put them back. All right, let's get started. You're going to use Notability today. I did say we're going to be using that for a reason. We've been doing paper all year. However, today's going to be a little bit different because I want y'all to take these notes with you to high school. Chances are you're going to probably lose your paper notebook between now and 9th grade and 10th grade. Next year, you're all going to be in biology, taking biology. Very beginning of biology, you're doing biomolecules. And you're going to need to know a little bit about bonding with biomolecules. So, to make sure you're good, I want you to have these notes available next year. Thing is, at the end of the year, turn your iPads in, you lose your iPads, they wipe them and everything. So, what we're going to do is right when we get back from spring break, we're all going to get together and back up our notability, especially this chemistry section we're about to do now. So, once you get your iPads next year, it will be saved. So as soon as you get your iPad, you open up Notability, boom, it's right there. You can reference it right away. So when you're in biology, you're in chemistry, you're good. Okay? Let's get this off real quick. Okay. So I know it's going to be different. We have not used Notability at all this year because we're all paper. But I just need you to go with me with this. All right. So you can open Notability. You can make a new one for chemistry. Okay. See, I haven't used mine so long. It still says 2023. That's how long it's been for me, right? So you're going to actually, and my actual folder says 2021, 2022. You can create yourself a new folder and such. I'm going to use GoodNotes just because I'm using software on my computer called OBS Studio. And Notability and OBS Studio do not talk well. So I'm going to use, OBS Studio and Notability don't talk well. So I'm using GoodNotes, but you can use Notability. This is fine. Those are all my other windows. Sorry. All right. So to get our template, you're going to go to Canvas, and I'll get you a moment to do this. You can go to the very bottom. You might hit refresh, but you'll see Bonding Notes Template for Notability. You can open that up. Right now it's blank because I'm doing it right now while there's a video. Once this video is done, it'll pop up. You open up that template and import it to Notability. I'll let you do that now. Do a little waiting. It's time to make that now. I'll talk while you do it. So while you're uploading that, this video I'm making right now will be available to you later on, say next year in biology. You're talking about four different biomolecules like lipids, carbs, and everything. And you're like, oh man, everything about covalent bonding, ionic bonding, I need a little refresher. This video will be available. Thing is, this Canvas course will not be here. This video though, however, if you go to Studio, the Studio app on Canvas, it'll be on the left-hand side. It's like a little picture with the, like a little TV screen with a plus and little cables on the bottom. So the left-hand side, third from the bottom. You click that, I'm going to share this with everybody. You can actually watch this video again. It'll be saved for you. But also, when I get done with this video, I'll actually put the link to this video again below the notes template. So you can watch it again Tuesday or Wednesday. Because we will have a quiz over bonding on Wednesday. All right, it'll be a 16-question quiz on bonding on covalent ionic bonds and Lewis structures. So you know how to make Lewis structures, a single, double, triple bond, and difference between covalent, ionic, and metallic bonds. Okay, you should have uploaded by now. All right, let's go to the first page, which looks like this. I kind of gave a basic structure for you real fast. All right, in the very top, we have bonding. That's what we're going to be talking about, where two or more elements are going to go slapping together and holding on. They're going to be bonded. One atom, another atom, holding together. That's going to be bonding. Like holding hands. Two people dating, holding hands. Right? But there's three types we're going to talk about this year, mainly two, but three is the total: covalent, ionic, and metallic. Today, Monday, we're talking about covalent. And this is where we're going to be sharing electrons. Covalent is where we're talking about with non-metal sharing with, did I just really misspell non-metal? Oh my gosh. Let me erase that all together. That was just trash. Shame on me. Non-metal with a non-metal. Okay. We're going to do a quick refresher from Friday because it's been a few days. It's been Saturday and Sunday. And we also had a PACT test on Saturday, so our brains are kind of a little bit. We refresh those structures. That's the first part of bonding. Okay. Notice below it, I only put nonmetals. We have hydrogen, boron, carbon, nitrogen, oxygen, fluorine, neon, helium, silicon, phosphorus, sulfur, chlorine, and aluminium. Okay. And I need to get me a periodic table real quick, because I realize I'm doing this without one. There we go. Of course I have one on my desk. All right, we're going to do the Lewis structures. Start off with hydrogen. Hydrogen is in group 1. And the 1A means we have one valence electron. So it gets one boop dot. Okay. Remember, if you want to jump ahead on this, you can. I'm just going to try and just refresh our brains. Boron. If we look in the periodic table, we see it's in group 13. It does not get 13 valence electrons. Valence electrons are on the outside ring, the pizza crust. It has a 3A above it. It has 1, 2, 3 valence electrons. Okay. Carbon, my favorite element of all, because it's the most versatile with bonding. It's the easiest to bond with. 1, 2, 3, 4. It's also the reason it's the easiest. It's why it's the part of life. In biology, almost everything in biology deals with carbon. Okay. Nitrogen, group 15, has a 5A up top. So it has 5A. It has 1, 2, 3, 4, 5. Notice how all of a sudden we have 2 up here. We only go 2. We're going to be playing with that today. Okay. Oxygen, the stuff we're breathing in. We also breathe in nitrogen too, but oxygen, 1, 2, 3, 4, 5, 6. Okay. Fluorine, we're in a gas. 1, 2, 3, 4, 5, 6, 7. All right. Now we have these 2 on the far right. These are in group 18. Now these guys are known as noble gases. They're stable. They have a full outside ring. We have helium and neon. Now, helium, depending on which class you're in, I made a mistake I want to correct real quick, because I did make a boo-boo. My first period, I told you like this. And I realized, yeah, it's true, but I want to make a correction. If I told you like that, I want y'all to not do it that way. Helium, I want y'all to put them together like this. It's really, electrons just don't want to be like that alone by themselves. They kind of like that. So for helium right now, I'll explain more tomorrow and Tuesday. But for helium, put the 2 electrons it has together. We'll see why later, okay? All right, neon, it's in group 18, 8A. 1, 2, 3, 4, 5, 6, 7, 8. Now, both of these are in group 18, but why does helium only get 2 and neon get 8? Let's y'all think about that for a second. Why does helium get 2, but neon get 8? Oh, let me get rid of the waiting guy in the bottom right. I'm sorry. There he's gone. Right, so Helium is in period 1. There's only 2 elements in period 1. So there's only 2 elements, there's only 2 electrons available. So that's why everything in period 2 only get 2 electrons. So he's actually a full ring, right? Now, in period 2, you had a total of 8. He gets a full octet. Or oct means 8, so a full octet is 8. So that one gets a total of 8. So this has a full ring. Oh, that was a horrible ring. And this has a full ring. Okay. Let's go to the next part down here. Silicon, number 14 over here. Has 14 electrons, but we're doing just the outside ones. Silicon has 1, 2, 3, 4. Because it's in group 14, they have that little 4A on top of the groups. If you're struggling, always reference the sheet we had on Friday, which I do not have directly in front of me. Thought I had a copy of it, but I don't. All right. Phosphorus, 1, 2, 3, 4, 5. Okay. Let's go to S for sulfur. Into group 16. 1, 2, 3, 4, 5, 6. Okay. Now this is just we're just refreshing our brains from Friday. Chlorine. And I realized I put an AL in the end. That's the wrong one. We'll come back to that in a moment. Oh, I put aluminum. I want everybody to scratch that out. Okay. Chlorine. It's in group 17. 1, 2, 3, 4, 5, 6, 7. Group 17, but there's a 7A right below that 17. So 7 valence electrons. Okay. Let's go and just check that real quick. I'm going to go to the periodic table. Okay. It's right here. Let me get rid of that stuff here. Okay. Right here. There's 7 valence electrons. So that means I have 1, 2, 3, 4, 5, 6, 7. Check it, 7A. Okay. Go back to where I was. What page was I on? Right here. Okay. Now I realized I put Al, aluminum. I meant to put argon. So let's put AR over here for argon. Now, argon is a noble gas. Everything in group 18 is a noble gas. A noble gas. I know from my 2-3 block I was messing with y'all and I put a K in front of it, but noble is with just an N. Noble gases are very stable. They're non-reactive. Actually, argon is so not reactive, they put the Declaration of Independence in a glass case sealed with argon so it does not react with anything in the air to break down. It's so stable. So they put it in there so it doesn't do anything. Okay, I want y'all to build argon real quick. So it's in group 18. I'm not even going to put it in the notes. I'm going to make sure you all got it. All right. Now let's talk about bonding. So we go down here to bonds. And actually, I'll give everybody a chance to catch up just in case I'm moving a little bit too quick because I know I'm not there to pause the video or anything. But if the video does need to pause, please tell us up. Just hit pause for a moment. We'll be good. Okay, we're good. All right, so let's go to bonding. So bonding is where you have one atom. Hello, I'm an atom. Another atom. Hey, how you doing? Hey, what's up? And they're going to all going, hey, grabbing each other, and they're holding on, right? They're holding on to each other. Now, physically, there's not actually arms there, But think of like magnets. Magnets has like a charge, right? Like think of positive and negative end. And this atom has a positive and negative end. The negative ends of magnet, and like this piece of magnet, the forces are holding on to each other. So the electrons of an atom have a charge. Electrons of these atoms have a charge, and those charges are going holding on, right? Well, that's what's going to be happening with these atoms, okay? And there's bond types. There's singles, one, double bonds, twos, and triple bonds. There's no four bonds, no quadric bonds, only singles, doubles, and triples. So if you see one type of bond, it's a single bond. See two bonds, it's a double bond. See three bonds, it's a triple bond. They look very confusing at first. Just like the Bohr models, at first they were really hard. But once we play with them a couple times, they're gonna get really, really easy. So if you're confused today, don't worry. By end of tomorrow, in a class, I will make sure you're good. Remember, I'm gonna be in class tomorrow. I'll make sure you're good before you leave class tomorrow. Okay? All right, the first bond we're gonna do is a single bond. It'll get the formula H2. Now H2 is gonna be a compound. We have two elements. Sorry, we have hydrogen and hydrogen, two hydrogens, and they are connected together. So we have a hydrogen here. Let's draw the Lewis structure for this hydrogen. It has one electron. We have this hydrogen over here. One electron. Now, remember about reactivity. Every atom is not happy unless it's in group 18, right? Why am I doing it holding the paper? We have an iPad. Oh my gosh. Why am I trying to hold paper to the screen? That's so stupid. So much better. Every element wants to be a noble gas. These guys right here are so happy. These noble gases are stable and happy, right? They have a full stomach. Full stomachs. After Thanksgiving, you eat food, and you're like, oh man, I'm so happy. Just laying back in the little recliner. You don't want to do anything. Your belly's full. If your belly's not full, you want to react till your belly is full, right? So, everything has a goal to become a noble gas. Right now, we have hydrogen. It has one valence electron. Is his belly full? No. On his ring, on his period right here, he only has one valence electron. How many can he have on his valence electron? Two, right? I'm going to draw a Bohr model. Do not draw this. All right? So you have hydrogen. Right? One electron. Is his outside ring full? No. Remember, this period can have up to two of them. He wants to be here. How can he be like this guy? Well, if he can get one of these, would he be happy? Yes, he would. He'd have a full belly. So here's what he's going to do. Let me go back to my page. He's going to go to his friend. Hey, hydrogen. Hey, other hydrogen. I have an idea. Would you want to share your other electron with me? In this case, if I have my electron and you share me your other electron, I have two. You have two. I'm full and you're full. And we'd both be happy, right? They can do that. So this guy's like, well, hey, how about you share yours with me? They're going to do that. So here's what it's going to look like. This electron's going to move over to this side. He's like, hey, and hey. And they're going to hold hands. And like this. Like they're walking down the hallway holding hands. They're bonded. Think of it as like, don't draw this. Don't draw this. Boyfriend, girlfriend walking down the hallway holding hands. They're bonded, right? One hand across, they have a bond. Are they happy? Yes. One electron, two electrons. That's a single bond. It might be confusing. I'm going to do it one more time. Okay. Draw the Lewis structure. You have hydrogen, one bond. Sorry, one electron. The other hydrogen, one electron. They're going to share electrons, so their belly becomes full. Right? Now, electrons here, electrons here. They're going to be able to share by holding the hand. Now they're complete. They're like they're dating. Now, if we ever have a bar represents two electrons. So we're going to go up here and go to bonds. One bar. I'm going to actually change colors for this. Y'all have notability. Equals two electrons. Okay. Remember, one bar equals two electrons. Okay. Now I got this. Now I'm going to do two more. I want you to follow along because it's not always just two elements. We're going to get a little bit harder, then we'll reset a little bit and do it a couple more times. And I'll give you practice, okay? Just remember, it's going to get hard, then it's going to get, oh, this is going to be easy. All right, next is going to be CH4. We're going to write down, oh, hold on, I have my display going on back here. Oh my gosh. Sorry, I didn't realize my stuff's going on. All right, I want y'all to write down carbon. Oh, it's in blue. Carbon and hydrogen. Now we have four hydrogens, right? I know it's silly, but I want you to write the Lewis structure for four of those hydrogens. Carbon. It's in group 14. The 4A, so it has 1, 2, 3, 4. Hydrogen, 1, 2, 3, 4. Now we gotta think, how can we make these all fit? Okay. This is gonna just take some practice seeing how these work before doing these little puzzles. So for right now, just follow along and you'll see it. Okay. Whenever you have a carbon and a lot of H's, you always want to put carbon in the middle usually. You're gonna make your life easy. Let's start with carbon in the middle. Now carbon has 1, 2, 3, 4. Okay, I'm going to take a hydrogen. I'm going to put a dot here. Okay, now can these hold hands? Yes, they can. All right, so I'm going, just to make my life easy, mark these out so I keep good count. Okay. I'm going to put another hydrogen over here. Okay, that one can hold hands. Mark them out. Put another hydrogen over here. That could be holding hands. Mark them out. Another hydrogen. Put that over here. You can hold hands. Mark them out. Okay. Now let's count. Hydrogen. 1, 2 electrons. Is this hydrogen happy? Yes, it is. Is this hydrogen happy? 1, 2. Yes, it is. Is this hydrogen happy? 1, 2. Yes, it is. Is this hydrogen happy? 1, 2. Yes, it is. But what about carbon? Now, carbon, he is right here. he can have 8 on his ring. So, let's see about him. These are all the ones he has. 1, 2, 3, 4, 5, 6, 7, 8. Is carbon happy? Absolutely. All right, now we have that. Let me show you how we cannot do it. We cannot, remember, this is wrong. Do not draw this. Hydrogen cannot be sitting here like this and having like 1, 2, 3, 4, stuff like that. Hydrogen can only have 2 on his ring, so you can never put multiple with hydrogen. All right? You gotta think, how many max can I have? If hydrogen is on period 1, he can only have 2 electrons belonging to him. Okay, so right now it's a little confusing. After playing with them for a while, you'll start catching on to these things. So right now, just follow along and you'll start seeing them patterns, okay? It's like when the first time you're doing like the alphabet, A, E, I, O, U, and the vowels, it will catch on. Trust me. Okay. Let's do one more. Remember, these are single bonds. I know we have 4 of them. But, however, there's only one bond happening here. You're doing by the bonds on these spots, on these locations. Not total, but this is a single bond. 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 If we had 2 right here, that would be a double bond. If we had 3 right here, that would be a triple bond. But don't worry, those are actually pretty easy. One more single bond. Okay? NH3. So NH3. 1 nitrogen, 3 hydrogens. Right, I want you to try that real quick. I'm just going to give it a little moment. You play with it. I want your brain to rack a little bit before I do it on the screen. Okay. I'm gonna first draw my dots. 1, 2, 3, 4, 5, 6. Wait, no. Let me get my periodic table real quick. Trying to do these in my head, and that's a dumb idea. Oh, 5 valence electrons. 1, 2, 3, 4, 5. Okay. 1, 1, and 1. See, I guess even after doing this for so many years, I still use a periodic table. Don't just assume. Okay, so let me now do this. If you think you got it, cool. Just follow along, just a double check. So hydrogens are usually almost always on the outside. Start with nitrogen in the middle. Put my little dots around it here. Get my 5 dots. I'm going to put my hydrogen. Now I'm trying to think of where do I want my hydrogen. I could put it here, 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 here. If I put it here, the problem is if I try to make a connection, it's not going to really work there. I want to be single. If I do it here, it means I'm going to be sharing with 1, 2, and 3. That's not good. So I probably want to put it here. It would use that 1 and 2. Okay. So hydrogen. Oh, okay, maybe that one connection there. Get rid of those. Okay. I got 2 more hydrogens to go. 1. Oh, made that connection there. There we go. Do another hydrogen. Oop, another one there. And it's gone. Okay. You may notice there's something different with this one. I got 1 bond, single bond, another single bond, another single bond. All my hydrogens are used, my nitrogen, but I have 2 electrons sitting here still. they're not bonded. That's okay. Those are called lone pairs. They're fine. They're still happy because nitrogen is happy. He still has 1, 2, 3, 4, 5, 6, 7, 8 electrons. He's good. His belly's full. Hydrogen's full, 1, 2. This hydrogen's full, 1, 2. This one's full, 1, 2. Okay, that's single bonds. We'll come back a few more times playing with things, okay? All right. Let's try a double bond. I'm only going to do one double bond right now. I want you to play with it a bit more in the practice, okay? All right, a double bond. CO2. I'm going to list these out. C, O, and O. 2 O's, so we have 2 oxygens. Remember, we're not doing any coefficients right now, so no numbers up front or anything. We're not doing any brackets yet. CO2. Carbon, 1, 2, 3, 4. Oxygen, 1, 2, 3, 4, 5, 6. Oxygen, 1, 2, 3, 4, 5, 6. All right, gotta think of, let me get rid of my little waiting guy at the bottom right. Bye, dude. Okay. How am I gonna make him fit in there? Well, it's kind of a puzzle. I could put O in the middle, and C and O in the left and right. But usually if I had something odd in there, I probably wouldn't try with him in the middle first. I mean, I could try with O in the middle, but usually if there's one guy different than the others, you probably wouldn't try him in the middle first. It's usually how it makes it work better. So let's try putting our carbon in the middle just to make things easy. Carbon. Put dot, 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 dot. Okay. And let's go and just move him out of the way. Let's put our 2 oxygens on the outside. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, those are taken care of. Now we've got to make them connect. We've got to make sure each one has a full belly. Right now, carbon, he needs 4 more to have a full belly. Right now, oxygen needs 2 more to make a full belly. This one needs 2 more. So we got to play with things a little bit here. Okay, so right now, let's connect the ones we do have connections with. Let me connect here. We can go and connect here. Okay, we can make that happen. Now, with these here, we can make these move and shift. So I'm going to go ahead and move my things here. Oop. Good thing notability, we can go boop, make these things move, right? Let's go ahead and do that in our notability. Actually, why even move that one? That's my bad. Let's go and just move these around. Okay. Well, we're looking pretty good. Let's see what we got now. Does this oxygen have 8? Oh, well, I already catch up. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Does this carbon have 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Does this oxygen have 8? And by the way, there's something wrong with this one when we come to it. 1, 2, 3, 4, 5, 6, 7, 8. Yes. We're good. Except, here's a new rule. Look at this oxygen. See these lonely guys over here? These lonely guys? Electrons don't be like floating by themselves. We don't float by ourselves. So what we want to do, we like lone pairs. We want to make them go zip next to each other. Remember that helium? Talk about we don't like 2 electrons floating by themselves inside of helium. We make them go zip next to each other now, okay? Just make them pairs. Just pair them up. Okay? Just pair them up now. That's it for double bonds. Yet we have 4 of them. We have 1, 2, double bond. 1, 2, double bond. 2, double bonds. I know right now your brain's like, wait a minute, wait a minute, wait a minute. Give it a bit. After playing this today and tomorrow, you'll be good. Now let's take a pause. Pull out your pink sheet. Pull out your pink sheet. We've been working on Friday and then you checked. Okay. Now if you're looking at your pink sheet, let me actually go to it. I have it on here. Nope. Okay. I want you to notice when the side that says covalence, we have a non-metal, right? Non-metal. It's only with non-metals we're playing with today. No metals. So we're doing covalent bonds, holding hands of non-metals. Right now we are sharing electrons. They're holding hands today, right? So I want y'all to make this big old connection with today's stuff. Go to the top here. Sharing / holding hands. Really holding electrons. I know it's a silly little connection, but please, 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 we're sharing. Sharing is caring. Okay. At this point, we're all going to catch up. If we're not here, please ask us out to hit pause. If everybody's good, we will move on. Cool. Let's move on to triple bonds. After that, we'll work on our practice. And where's my page? All right, triple bonds. Okay. Next one is going to be N2, 2 nitrogens. It's a simple little compound. There's a nitrogen and a nitrogen. Let's draw the Lewis structures for these 2 nitrogens. A nitrogen is in group 15. So it has 1, 2, 3, 4, 5. That's it. Make these a bit bigger. I'm sorry. 1, 2, 3, 4, 5. All right. Now I want you all to try using the skills we did a minute ago and try to actually build the bonds here in the same exact way. It doesn't change for this. We're just adding another line. That is it. So I want you to try it on your own, but as you're trying it, I'm going to do the same thing on the screen. All right, I made one connection already. I'm going to move my electrons around to fit in between. Got 2 lines. Now my problem is I have a lone pair up here, a lone pair up here, but a single one here and a single one here, and we can't have single ones. So they're actually going to come jump on this side over here, and they're going to hold hands again, because we can't have singles. Now we have 3 holding hands, and it's done. Triple bond, can't go anymore. If it does, that's probably a bad thing. Triple bond. Single, 2 electrons. Double, 4 electrons. Triple, 6 electrons. Let's make sure we're good. Nitrogen. Does he have 8 electrons? Is his belly full? 1, 2, 3, 4, 5, 6, 7, 8. He is happy. This one. 1, 2, 3, 4, 5, 6. 7, 8. He is happy. Okay. Here's what practice we're going to do. I'm going to do one more, show you how to do this one piece of practice here. After that, there's a key that's on the desk, right? The key, again, is going to be in pink. Not this sheet, though. It will be in pink. Once you think you're good with it, you're going to go up to the desk, check in pink, see if yours matches the key, if you're good. All right? Once you're good with that key, in blue, bright blue is the practice for today. Okay? It's going to be in non-metals only covalent bonding. You're going to do the practice for today. All right? It's going to be due tomorrow. Which complete the practice, you'll turn it in. So let me do this one practice question here as a walkthrough one more time. When you complete it, go to the table, check it on your iPad, take your iPad up there, check with the key. Once you're good, turn your stylus in. If you borrow my stylus, grab the bright blue practice sheet, work in the practice sheet for the day, okay? To make sure we're good. Okay, let me do the practice sheet one more time. Or say this, one of the practice problems to make sure one more time that we're good to go. H2O, water. Right, hydrogen. So H2O, we have a compound of hydrogen. We have two H's, and oxygen. Built the Lewis structure. Let's build the bonds. All right, got an H, got an H. 1, 2, 3, 4, 5, 6. I know it's 6 by looking at the periodic table. Group 16, 6A. I'm going to start making my connections. That's the easy one. All right, I'm going to move this one over here. Make a connection. Oh, this can only have 2, not 3. So I'm going to move you over here. Okay, 1, 2. He is happy. 1, 2. He is happy. 1, 2, 3, 4, 5, 6, 7, 8. He is happy because oxygen has kind of up to 8 in that ring. Good to go. So I'm going to put down here single bond. Okay. So now I want you to do is do this one for fluorine. Sorry, not fluorine. 2 of the fluorines. 2 chlorines bonded together. And this one's a little bit different, but this is good. This is a hard one. A carbon bonded with 4 chlorines. Here's a hint. The carbon will be in the middle. Okay? Carbon will be in the middle. Once you complete this, go to the front desk. And a bright pink will be the key for you to check to see if you're good. If not, go back and see where you messed up on. Make sure you're good with it. Then turn in your stylus. Grab the bright blue practice sheet and work on that. That will be turned in for the homework piece for grade. Okay? For tomorrow. Tomorrow we start working on ionic bonds. Ionic. Okay? And Wednesday morning we'll start off with metallic bonds. And then we'll have a quiz. Okay, I will be here a little bit in the beginning of Wednesday before I have to leave out at 10 o'clock. Okay, and so you'll finish the quiz before I leave on Wednesday. But we'll quiz over Lewis structures, covalent, ionic, and metallic on Wednesday. Okay, well, remember this video will be posted in Canvas if you need to go back and rewatch it after this. Have a fantastic day. And just for the fun of it, you gotta play the video.